Consortium for IT Software Quality very quickly so you'll know sort of what the background is for the webinar we're having today and for the OMG's recent announcement about a specification for automated function points. And then I'll turn it over to David Herron, who will give you an overview of what this means for the field and a bit on the specification itself. The Consortium for IT Software Quality was co-sponsored by the Software Engineering Institute at Carnegie Mellon and the Object Management Group. The original reason for starting it was increasing requests for specifications for automated measures, for automated software measures, for sizing and for quality management. 24 companies joined the consortium when it was started. You can see here some IT organizations inside large corporations. You can see large system integrators and outsourcers, and you can see some small companies like the David Consulting Group, for instance, that joined because they provide products or services into the IT world. So it was a large collection of companies who came together to work on creating specifications for automated measurement because we needed some common standards for quality measures that were appearing in contracts and to try to automate sizing to reduce the cost and increase the consistency. The original work with CISQ was done in executive forums. We had three, one in Washington, D.C., one in Frankfurt, Germany, and one in Bangalore, India. And executives came together, and many of them decided to join, and they laid out their requirements for what was most important to them, which measures they felt they needed automation of most. And you can see here the 5 measures that they picked. Sizing measure, they really wanted to automate function points with as closely as possible to the counting guidelines that are maintained by the International Function Point Users Group, and also quality measures for reliability, performance efficiency, security, and maintainability, because these are increasingly becoming parts of outsourcing contracts as ways to control the quality of the work that's being received. And so CISQ formed working groups of people from the member companies to begin defining these metrics and defining ways to automate these metrics. And as they're completed, they go through OMG's standards process. OMG has what they call supporting specifications, which is the equivalent of a standard. The first one to go through that process was the work that David Herren led on automated function points. That's gone through the OMG process. It is now a supported specification of the OMG. The document is going through its finalization process, and it's available for use. And we believe that there'll be some products in the market within the second quarter from various vendors. Once it goes through OMG's process, we have now a defined measure. We'll have more as we continue on with the CISQ work. OMG has a fast track over to ISO, so some of these will go into the ISO world, and then we'll hold deployment workshops, which I'll tell you more about after David's presentation. So this is sort of what CISQ has been trying to do. The work it's been doing. Our first automated specification was for function points. And it's now been approved. It was developed by an international team. There were Americans, Europeans, Indians, a number of others involved in this activity. What you see up here is the sort of the specification front cover. It's available on the OMG website, and it's also available on the CISQ website in the members area. We encourage you to join. It does the best job we could do of trying to mirror the ISPUG counting guidelines, but decisions had to be made in order to make this automatable. So there may be differences, but those differences are primarily in service of making this an automatable specification. And as I said a minute ago, we do expect commercial implementations of this specification to be available from various vendors in the second quarter of this year. So this is it's an exciting time for CISQ to start seeing these measures that we've worked on the last couple of years begin to make it through the OMG process to be available from commercial vendors and to start helping change the way that software measurement is done to make the counting process, in this case, cheaper so that people can spend more time on the analysis process and understanding what controls productivity and quality and how to make better estimates. So our featured speaker today is a recognized expert on function point analysis, David Herren. David is the co-founder of the David Consulting Group, He was the lead author and the team lead for the CISQ work on automating function points. David and his colleague David Garmis have what is, many can consider to be the leading book on function point analysis. I do recommend it to you. It's a very easy read, a very good read. And David is going to tell you from his experience and from his work with CISQ what he believes this means, this automated specification means for the future of sizing and function point analysis. So with that, let me turn the mic over to David, and he'll make his presentation.
Thanks, Bill, and welcome everybody. As Bill said, this really is an exciting advancement in the software industry, and I think I speak for CISQ as well as Bill. I would say I think part of the desire here is that we consider this as a community and work together to further advance these types of automated solutions and work as a community to improve the practices surrounding software sizing. So with that in mind, what I'm going to be talking about briefly this morning, I thought it might be important to, or that it would be important to, just talk about sizing in general and why is it important. And this is probably from my perspective as a function point and measurement practitioner for over 25 years, just to talk about the importance and why we're even here today in that regard. Then to share a little bit of information about the current state of functional sizing, kind of what's going on. And then boldly go where no man has gone before, perhaps, or where few have ventured before, but talk about the automating of function point sizing, how it can be applied, the benefits derived from it. I also want to, express and share and be totally transparent, if you will, about the other side of the coin. In other words, what can it do, or what won't we be able to do? And then, as Bill said, share a little bit about the standard. Just give you some insights into that. As he mentioned, it is available for public consumption, so I would invite all of you and encourage all of you to take a look at the specification in all its glory. And then we'll take a look into what the future of software sizing with automated function points may look like. Again, obviously this is from my perspective and my experience in the industry. So function point sizing, basically when we talk about function point sizing, we're really talking about the quantitative measurement of the software deliverable, being able to measure its features and functions that have been requested and provided to an end user in support of their business needs, ideally. The way size is most often used, at least in our business and what we see, clearly it's used quite frequently as one of the normalizing metrics for performance measurement initiatives. It gives the ability to more accurately compare quality and productivity measures, if you will. And this shows in a number of ways in terms of how it's utilized. It can be utilized in improving estimating practices and techniques and methods. It can be used in performing baseline and benchmarking analysis. So a variety of uses in performance measurement. It has also some utilization currently in portfolio management, being able to allocate the costs of the various applications, monitor growth. We'll see throughout this presentation that one of the existing situations, if you will, with the use of function points measurement in its manual state, it's fairly costly to size application portfolios, and therefore we think that one of the benefits with automated function point sizing will be the economic argument for using automated sizing. Function points are also used in managing outsourced contracts, third-party vendor management. Talk about it as a software currency. We talk about it in terms, and we have a number of client engagements where we are measuring the cost per unit of work, if you will. And that unit of work is, in fact, function point size. And then we see from time to time that function point sizing, function points have made their way into being part of the overall dashboard, scorecards, or what have you, at executive levels, primarily to help improve decision making. So you can see that there is a rather varied use of the function point sizing technique, its versatility, and I think that bodes well for progress that we've seen made in the software industry. The current state, if you will, of functional sizing, as I've labeled it here. Over the years, as I mentioned, I've been involved with function point sizing for 20-plus years, and certainly over that time, the number of function point sizing methods have expanded rather significantly, I would say. You see a few of the sizing techniques listed here. I would say that the International Function Point Users Group, the IFPUG function point sizing method is probably the granddaddy of all of these. It dates back to the late 80s, coming out of IBM and released to the public domain. Very quickly picked up by AT&T, and AT&T was responsible for starting the first International Function Point Users Group and initiating that. So, and today they still enjoy a long-term history of utilizing function points. You also see up here cosmic function points, Mark II, the NESMA, Netherlands-based function point methodology. Basically, all of these are kind of derivatives, if you will, from the original IFPUG function point sizing method. And along the way, there's things like quick and early function points or function point light. There's different variations on the function point theme. But by and large, I think it's fair to say that functional sizing really has enjoyed a rather widespread usage. And that's marked by, if you look at the IFPUG community, members range across more than a dozen different international countries. There's a growing community of certified function point specialists. Those are people that are certified in the IFPUG method of counting. But all of these function point practices have that basic principle that I read on the initial slide, and basically the quantifying of features and functions of a software deliverable. The type of counting, if you will, that's predominantly being done is manual counting. There are some automated tools or some tools that automate what they're calling function point size, and in fact are function point sizing tools. But most of the function point counting work to date is done manually, done by certified function point specialists or what have you, or any individuals that have gone through and have learned the technique and the process. So we see a lot of manual counting. And I would also want to point out that the functional sizing that's done is for both projects and applications. So you can functionally size a project. You can functionally size a project early on in the life cycle, and of course you can functionally size an application. Basically, function points can be applied as soon as you are aware of or knowledgeable of the features and functions being required. Function point analysis can be applied to the software problem domain that you're looking at. Most of the work and we'll see more on this momentarily. But I would contend, at least again from our experience within David Consulting Group, we're doing manual accounting, and most of the accounting that we're doing is project-based function point sizing. And again, part of the reason for that, a big part of the reason for that, is that it takes far more effort to count an application typically, and when you think about sizing a portfolio of applications, some of our clients have portfolios that are in excess of 5,000 or 6,000 applications. It becomes cost prohibitive to manually size that many number of applications. And we'll see and talk more about that, as you might already presume. That's one of the selling points here of function point sizing automation. From time to time, we at David Consulting Group survey the industry on a variety of measurement-related and function point-related topics, and we just happenstance have just recently finished a survey on function point sizing. And one of the questions was asking the respondents how they utilized, asking them if they used function point analysis, and not really clarifying which technique they used, but more importantly asked how they used the function point sizing technique. And you see the results here. They could answer more than one type. So you see things about cost apportionment across the application, reading along the bottom, things related to performance measurement, estimating, outsourced contract management, budget planning, so a variety of things. And you see, and I've highlighted here, and I hope the colors come across, but I've highlighted the internal performance measurement and estimating development projects. And as those are the ones that are experiencing the greatest usage. So the survey data doesn't support this, so my speculation would be that one of the reasons anyway that these are more typically areas where function points are utilized is because it's measures of projects more than applications. You estimate a project. Performance measurement is best done at the project level. And that's where the manual counting activity goes on today. And so, again, just my view of this survey data and speculating that that may be one of the factors as to why these two categories are so commonly used. Conversely, it would also suggest to me that don't we have an opportunity here if we look at cost apportionment across applications, if we look at vendor performance measurement, if we look at things like outsourcing contract management, relatively low experience in terms of utilization. And so doesn't this present an opportunity for growth in the function point community and the utilization of function points? So again, just some industry interesting survey data from a cross-section of the various industries that we surveyed. And I just thought it would be appropriate to show it here and try to help drive home the point of not only the overall expanded coverage of function point sizing techniques, but there are plenty of opportunities looming on the horizon where we could increase the overall utilization of function point sizing. And so, as you might expect, that would lead me into talking about the automating of function point sizing. And why would we want to automate function point sizing? And again, the CISQ specification that we're talking about here deals solely with the automating of function point sizing at an application level. So we haven't tackled the challenge of being able to size projects. So we're talking about automating function point sizing at the application level. So first and foremost, and what leads the way is obviously the economic argument for doing this, the efficiencies that you would get manual versus automated sizing. And in addition to, we talk about perhaps more cost-effective to look at application portfolios, gaining a greater level of granularity, ability to allocate costs perhaps across the application portfolio, which is a stated need by our clients, and today in a manual accounting way, they're just not able to do that economically. Another plus for automating function point sizing certainly is the consistency with which you get with automation. One of the statistics, I guess, that floats around out there is this notion of what is they talk about accuracy, but what's the variability in manual counts. So if you have two counters counting the same, in this case application, independent from one another, IFPUG has stated through a statistical analysis piece of work done at MIT a few years ago, will say that the difference between those two counts will be plus or minus a variance of plus or minus 10%. Our experience within David Consulting Group is plus or minus less than 5%. So pretty darn good, but still there's a fair amount of variability, and if you consider that variability across a portfolio of applications, you could be talking about some rather big numbers. Certainly consistency in the terms of, again, accuracy, if you will, kind of loosely stated, but certainly repeatability, and obviously the ability to do some new and adventurous analytics that perhaps we're not able to do today, again, as we analyze application portfolios. I think another issue here is the credibility, and I talk about it here in terms of the ability to perform. There is a natural mindset that because something is automated, and yes, so therefore it'll be consistent, more consistent, greater consistency, no variability, and that would add credibility to it. And so it might add credibility to the resulting sizing of those applications. And then finally, just the knowledge that would be generally gained making the case. And of course this would be for manual sizing as well, but wouldn't it be nice to allow organizations now to do a better job at overall portfolio management, do a better job at what I've called here third-party governance, or managing, third-party outsourcing arrangements by being able to properly size the applications that they are supporting or building for us, or what have you. Might also apply, there's a number of different ways to apply, but it might also apply as, sunsetting organizations, or looking at best fit applications for modernization, again, across a portfolio. So there's a lot of additional information to be gained and knowledge to be gained if we can open up the opportunities for automating function point sizing across the applications. The CISQ specification talks about all of these factors in with three terms. They talk about being consistent, which we have here, talking about being economical, and they use the word, we've used the word in there, verifiable. However, this isn't without some constraints, and as I said, trying to be totally transparent here as to what we have and maybe what we don't have. Certainly, in order to do this per the CISQ specification, the CISQ specification is an examination of source code, and so that source code has to be available. and we'll see a little bit more later on in the presentation, a little bit more about the details of the specification. But so you would need source code. This is not, the specification is not targeted at projects, so it would not allow you to use this sizing in a predictive project management way. And obviously, you would have to have the ability to deal with a variety of program languages, which we think we've dealt with in the specification. But proof will be when we actually have that software built and prove out the specification. So I thought, so making the case here for automating function point sizing, and I thought it might be interesting to see, how does this fit with what some folks talk about in terms of what makes an acceptable software sizing approach. I think I probably want to say at this point in the presentation that I interviewed a number of practitioners in the function point community when I was putting together this information. I didn't want this to be just my perspective. And so this slide actually comes from some of my notes from several of those interviews talking about what would make an acceptable software sizing approach. So clearly consistency or repeatability, and we've touched on that, or I've touched on that already. But obviously there's a major advantage in automated software sizing over manual sizing approaches, both in the consistency and the economics, as we've talked about. The issue of accuracy, and I've had some fairly interesting conversations with some of my colleagues about this issue of accuracy, asking about, how do we measure the accuracy of these tools and of these practices and whatnot. And as you can see here, here's a statement talking about that there's no real absolute standard for software sizing, so maybe it's not so realistic to test this automated software sizing solutions for accuracy. But a couple of people have talked about accuracy in kind of an interesting way. One of those is accuracy may be defined as accurately representing the features and functions of a given piece of software. So to the extent that you have a method, automated or manual, to the extent that you have a method that's able to do that, that could be viewed as a measure of accuracy. Another way that, as recently as yesterday, actually, a colleague of mine talking about all of this and asking about this issue of accuracy, talked about accuracy in the context of that the results are accurate relative to the adherence to the methodology or the specification. So again, the IFPUG notion that IFPUG function points, if you will, are accurate plus or minus 10%. That's really talking about two individuals independent of one another sizing the same piece of software and coming up plus or minus 10% relative to the IFPUG guidelines and techniques and specifications. And if you think of accuracy that way relative to our automated function point sizing specification, I would venture forth to say it would be 100% accurate. And then finally, relevancy. Obviously, the results must be purposeful, valuable to the business, to IT, and therefore the resulting size, it needs to be something that's well understood. And represents in and of itself some form of transparency. So again, all those that I spoke with and gathered, I hope you all understood that I was going to share some of your comments and whatnot, but I do want to thank those individuals for their input into this. I talked to IFPUG function point practitioners, as well as from other function point sizing disciplines. So again, thank you for that. So how is function point sizing automation a game changer? And we've touched on these things, and I thought I would expand them a little bit, and want to make a particular point as we get towards the end of this slide. But so if you look at and think about portfolio management, clearly organizations that need or want to allocate application costs across the board have no way today really to do it effectively. But with automated function point sizing, now they will. With a greater granularity, if you will, it's a good term, I think, granularity of the portfolio, they're going to be able to monitor growth, be able to monitor performance. Think about the situation where a company is acquiring another organization, and their application portfolio. It's going to provide them the ability to quickly size that acquired portfolio, and perhaps in some form of measure or whatnot, be able to judge or evaluate the value of that portfolio. Clearly being able to think about, think about sunsetting applications or what have you. There's also the issue of what I'm calling vendor governance, that software concurrency, that cost per function point, the providing of function point support on a function point by function point basis, but across a portfolio of applications. Improved ability or capability of setting up service level agreements based on function point size. Clearly, I think we'll see more in the way of production support and resource allocation, performance issues, performance measures. On the next slide, I'm just going to show a few fairly basic and simple measures that we probably could start using on a broader way, and more expanded way, I guess, with the ability to automate. And then this new opportunities for function point service providers. I think it's important to note some of the people that, some of my colleagues that I spoke with in the function point sizing community, consultants, vendors, provider of function point services, saw the advent of automated function point sizing as perhaps some way, shape, or form that it may negatively impact their business. And we at David Consulting Group have a different view of that. We in fact think that it could provide additional opportunities and expanded opportunities for function point practitioners. And I know not everybody on the line is a function point practitioner, but I think that it's, since there is such a large community of function point practitioners, whether it be IFPUG or COSMIC or NESMA, I think it's important to point out the advantages that this is going to be providing our clients. And I think the additional work that and opportunities for helping our clients will be the management in this, the management and analytics of the data that we'll now have. I know from our perspective, as I said, we don't do a lot of application sizing, certainly not on the magnitude that would be available through automation. So again, I think there's only going to be an expansion for service providers as opposed to any detrimental impact. Some simple usage of function points, some productivity metrics, some quality metrics, looking at application support rates or maintainability, some fairly simple basic quality metrics. Again, these are being used today on on an application-by-application basis, or maybe a small sampling section of an application portfolio. But now obviously can be used in a much wider way, again, across the entire portfolio. Getting near the end of the presentation, so I do want to talk about the CISQ standard a little bit, the specification. This is a very involved specification. There's a lot to it. Clearly, we couldn't go through all of it today, but as Bill Curtis mentioned in his opening statement, it is available in the public domain. I think it's appropriate to say we would love to have people look at this. Certainly, you can ask questions about it or what have you, but you know, I think if you have any specific questions today about the specification, it would probably be one way you can get some answers is to look at the specification for yourself. So I just want to hit some of the highlights. So the purpose, as you can see here, was really to create a standard for automating the sizing of software applications. I've underscored that. Based on function points. It's defined by the International Function Point Users Group. So, and Bill mentioned this, but the IFPUG standard was really selected as the anchor, if you will, for automated function points, primarily because it's the most widely used functional measurement specification, and it has a large supporting infrastructure maintained by a professional organization. So that was the model. That is what we, the task force, was focused on. The scope, it's functional sizing for transactional-oriented software applications. And we'll see momentarily, the specification follows the steps for the counting process that's defined in the IFPUG Counting Practices Manual. We follow that to the extent possible for an automated system. So this relies on, so you'll see that this automation relies on receiving the correct and complete list of inputs to fulfill that step. And so consequently, the initial step in the automated counting process is the manual gathering, if you will, of inputs and configuring them properly for analysis by the automated function point counting technology. And then the remainder of the analysis and counting process is automated. So there is an initial manual intervention, if you will. I should also point out that the specification clarifies, you know, as you read through, it clarifies points at which the IFPUG and CISQ standard diverge because of a requirement for automating. So the input, of course, you need source code, source lines of code, and basically there's a notation or the ability to list some of the exclusions, things that are in the source code and should not be considered as part of the sizing. And there's also some parameters. So basically, there's this minimum set of rules to capture the human perceived complexity, primarily dealing with things related to interfaces and storage. Once that's defined and whatnot, and the tool is set to run automatically, or the specification talks about the automatic processing, we're really following the IFPUG steps to detect the data functions, detect all the transactional functions, distinguish between internal versus external data stores, or as defined, logical files, and then calculating a total number of function points in the application. Clearly and rightly so and understandably, the outputs, you would get a list of all of the inputs used by the counting algorithm, so that upfront manual intervention is restated. You can see here there's a list of all instances where a pattern specified in input matches a pattern detected in the application. And then clearly a listing of the transactions and data functions and their weights and whatnot, with the appropriate totaling being done and providing a function point size. So again, just a quick overview, if you will, of the CISQ standard for automated function points. So just kind of wrapping this up and just hitting the highlights of what we talked about. We definitely think that this is going to result in increased use of functional sizing at the application level. And clearly it represents in the community an opportunity to more effectively and efficiently manage portfolios, as I talked about. I think too, and I haven't mentioned this before, but I think this looms large as well, and that is the increased coupling with structural quality code analyzers. There are any number of tools on the market that basically analyze the quality of code. And again, maybe a little bit editorializing here, I would think those companies would be wise to consider, since they're already evaluating and analyzing the code, it might make sense to couple those features and functions with automated sizing, thereby significantly enhancing their product deliverable to their client base. I think that automated function point sizing can improve the overall management of maybe not vendors per se, but vendor-related contracts. Talked about it in terms of the notion of different valuation methods, whether we're acquiring or talking about sunsetting applications or whatnot, better managing of our software assets, and clearly better insight into the world and of production support costs, and therefore hopefully being able to more effectively manage those production support costs. And so that concludes what I prepared today to talk about the overall view of automated function point sizing. And at this point, I will turn it back over to Bill. You there, Bill?
Here we are. Sorry, I was on mute. So I'm going to give you a few final notes, and then we'll go to the question and answer. We'll go to the question and answer period. First, this is sort of the follow-on to where we're going from here. We're going to hold seminars for helping people understand how to use and deploy the various CISQ metrics. These will be held this year at OMG technical meetings. You can see here the dates. There'll be one in Reston, Virginia, outside of Washington, D.C. on March 20th. David, myself, John Keene from the Department of Defense will all be talking about sizing metrics and quality metrics and our experience in using them and tips on how to best take advantage of these kinds of metrics. We'll have one in Berlin either the 18th or 19th of June, one in New Brunswick, New Jersey, just outside of New York on September 24th or 25th, and one in Santa Clara, California in Silicon Valley on December 10th or 11th. We'll get more media information out on those meetings. They'll be available on the OMG website. They'll be open meetings. Anyone can attend. Once they're announced, you can sign up and register for them. The content will be the morning session. We'll spend our time on sizing metrics and their use in productivity analysis, how automated function points can aid with that and in fact change the game, and how function points get used in a variety of ways and more frequently. Afternoon session will focus on the CISQ quality metrics for reliability, maintainability, security, and performance efficiency, and how those can be used and experience in using those kinds of automated static analysis metrics for quality management. So as I said, there'll be more information on these available from OMG as they develop, but the first one will be in Reston, Virginia this March at the OMG technical meeting. I invite you to go to the CISQ website. We've had some questions regarding where's the specification. The original specification was inside the members area of OMG. We've now begun the finalization process, and we can make the new specification available. It'll be available shortly, within a day or so, inside the members area of the CISQ website. You're seeing a screenshot here of the CISQ website, and you can see at the top the actual URL for CISQ. It'll also be available at OMG. So we'll get more information out on that shortly. In fact, we'll email everyone that's attended the webinar with information about how to get a hold of the specification. I'll mention in advance that parts of it may be hard to read because we had to express it in the various meta models that OMG uses for formal specifications. So it's expressed in both in the knowledge discovery meta model and the structured metrics meta model, both of which are object representations that OMG uses for all of the formal specifications that it produces in this area. So let me end here, and let's begin our Q&A session. What I just popped up on the screen there was a copy of the CISQ specification for automated quality characteristic measurement. That's now available from the CISQ website. We're beginning the process of moving that through the OMG approval for become, again, a supported specification of the OMG, but it is available today from the CISQ website. So let's move into the question and answer period. And we've got a number of questions queued up for both David and myself, and let's launch this from the top. And maybe, David, you can take the first one. Why would we size software after the fact?
Yeah, sure, Bill. I thought I was hoping that we answered that as we went through the presentation here, and maybe this was a very early on question, but I think it brings up 2 points. I'm assuming that the individual asking realizes the value of sizing during project development for predictive capabilities, et cetera, and better control and managing of a project, absolutely, and looking at performance at the project level. Measuring it after the fact, so that's where we talked about the ability to manage, improve management of the overall application portfolio, looking at issues dealing with the productivity and quality in managing that portfolio.
Okay. Let's get to the third question. What, if anything, about this specification limits it to transaction applications? What about utility software, operating systems, compilers, development tools, etc.? David, do you want to?
Sure, I can answer that. I can answer that in part. I mean, that's a constraint, if you will, of a functional sizing metric. It only measures the features and functions of the that are related to what the user has asked for. So operational, clearly, the non-functional types of system software that's out there is not measurable using a function point sizing technique, automated or otherwise.
Okay, we've had a number of questions that deal with what we're going to do to verify or test the validity or the accuracy or the usefulness of the specification. And that's going to come with experience. I mean, if we learn through experience in various vendors producing function point counters related to the specification, and we see changes that need to be made in the spec, then OMG has a process for doing that and for continually improving it. There is some experience with an existing automated counter that was built prior to the specification. David, in fact, has some experience in looking at the calibration between automated counts and manual counting. David, you want to give some of your experience results?
Yeah, the tools that we've been involved with to date that automate function point sizing have required some calibration, naturally so. We've hopefully, in large part, taken a lot of those experiences and built that into the specification to minimize the calibration. I think we're looking at this in an idealized way initially with the specification that we're not anticipating the need for any calibration. There is that initial manual intervention or input that's being required, just describing some parameters to the automated tool, but from that point forward, we feel that it will be able to produce results that don't require calibration. But, as you mentioned, Bill, I think it's only practical to assume that we may be less than 100% there, and time will tell with the proof of actually developing the software and running the software and testing it for its, as I defined it, for its accuracy.
Okay. Try one here. On accuracy, does Dave have a view? Whoops, so I hate this when it jumps. Yeah, does Dave have a view as to how accurate software measured with a tool correctly built to this standard will be compared to the same application measured by the standard, ignoring inconsistency between manual counters? In essence, I guess to what extent this will reflect the IFPRA guidelines.
Yeah, and again, we know. So, for example, the one example that I can tell you for sure, and you know, I don't mind again trying to be as candid and as transparent as possible here. The one issue that we had relative to identifying a particular feature or function is making the distinction between an output and an inquiry. And we were not able in the specification or in our research and analysis on all of this, we did not find a way to be able to make that distinction. However, and so I've talked to people in the function point counting community about that, and they, because of the weighting of those two being very similar and close to each other, they thought that was an insignificant difference.
Here's a question I'll take. Manual variability is quoted as plus or minus 10%. What variability is expected from automated function point sizing? And I want to answer that in two ways. If you're using a tool consistently and you have internal guidelines for how to set up the analyses and what you're going to include and what you're going to exclude, and you use it in a consistent way, then the variability will be virtually zero. In essence, the same tool on the same software under the same specifications for boundaries and whatnot will produce the same answer. And so if you have good controls internally, over time you'll build up a repository of data that is very consistent. Now, in terms of different vendors' tools, yes, it's, you know, I don't think two vendors or even two developers could ever take the same specification, regardless how rigorously expressed it is, and come up with exactly the same piece of code. So we know that there probably will be some differences between vendors in some of the algorithms and some of the counting. We hope it's closer based on this, but. So pardon me a second. But over time, we'll learn more, and we may learn some things we need to fix in the OMG specification as a result of seeing differences among manual counters, between automated counters. But we do believe as long as you use a vendor's tool consistently, you'll get consistent results. We don't think there'll be large differences now between vendors, and that's something we'll study as more counters come online to see if we can improve the spec to reduce any variation between them. Let's see here.
Probably have time for maybe 2 more, Bill.
Yeah. Let's deal with the issue. I've seen a number of questions related to it in terms of how do you deal with trying to estimate. I mean, this counts when you have source code. What do you do when you don't have source code, and what effect does this have on estimating, and what's the value of having these kinds of counts available if you know, even in a repository, if they weren't available during the time of estimating? You want to take that one on, David?
I'm not sure I understand it. What does one do if the source code is not available? What are the opportunities?
Yeah.
Well, you know, from our company perspective, or you know, if we were faced with that kind of question, and quite honestly, that happens. I mean, we face counting situations, function point sizing situations where, well, we're not counting from code anyway, but we don't have some of the pieces and parts that we would want to use to count from. So we use other means, and sometimes we actually, in the case of an application, we'll actually look at the application itself if it's a kind of an online transaction-based application, and our counters are experienced enough such that they can look at an application and not only obviously see the I/O that's going on, the inputs, outputs, and inquiries that have to be accounted for in function point analysis, but can also make some determination as to what the logical files would be, and can get some input from the users of the application as to perhaps what other applications they interface with. All of these pieces and parts go into a function point analysis sizing method. So, you know, obviously from a CISQ spec automated sizing tool perspective, without lines of code, we can't do anything.
Yeah, and let me to add to that if you are using a formal notation for expressing requirements, or especially for expressing designs, you know, we can build a parser to analyze what's expressed there, and then look at how we might build some counting rules to deal with that. And my guess is the current specification would probably help us cover analysis of formal notations of things that are expressed at the design level. But more importantly, as you continue to develop automated counts, you're going to have a repository, and you'll be able to calibrate that repository against things that you're doing up in the analyses you're doing up in the design phase to get more and more accurate understanding how to best estimate before you have source code that you can automatically count. But again, that's an experience issue, and we've seen people, with regardless of what sizing measure they're using, as they keep a repository of existing data on previous applications and development projects, they learn how to get better and better at building their estimates early on based on their past experience. So let's end it there. David and I will take, yeah, David, go ahead.
I was just going to say I think we've run our limit on time, and so
exactly.
do you have any closing remarks?
Do you want to make some, David?
Sure. You know, I would just repeat. You know, these questions and whatnot just call to mind what I stated in the beginning, and I hope all of us will work as a community to advance this and improve these specifications and these opportunities that are before us. So I think if we think of ourselves as of a community of practitioners all working towards the same end goal, and I think we'll see great advancements in the future.
And thank you, David. And certainly what we're trying to do with CISQ is create that community that David talks about and help advance the science and practice and benefit of software measurement, and driving it more and more towards automation is certainly one step in that process. And as we gain more experience, we'll have more valuable material on the CISQ website available to members. So thank you very much for attending. David and I will take these questions. The ones we didn't answer or have time for, we'll look at providing answers for and circulate those to the people that attended and registered for the webinar. So thank you very much, and that ends today's webinar, and good luck to you.
Thanks.